Hello and welcome to the AMCI tutorial. With this tutorial, we assume that you already know how to add an AMCI drive to a PROFINET network. If you have any issue with this procedure, please refer to our tutorial that explains how to add a drive to a PROFINET network. So in this tutorial, we will talk how to perform some basic moves with an AMCI servo drive that resides in a PROFINET network. These are the topics that will be covered in this tutorial: downloading the sample programs with the library, configuring the servo drive, adding components from the library, compiling and downloading the project to PLC, and on the end, performing basic moves. It is recommended to download a zip archive file that, besides sample programs, contains a library with many components as functions, data blocks, and PLC tags, which will be used in this tutorial, and it will definitely make your programming efforts easier. Now we're going to open the library, select all needed components from the library and add them to the project. Then we're going to use all those important components and build our program for this tutorial, and then we're going to compile and download the project to the PLC. So I already have opened my new project. As you can see, there is already a PLC. I already have established the PROFINET network and added the servo drive to the network. So before I go to the library and add those components, I'm going to briefly open the properties of that servo drive, and under the module parameters, those configuration parameters, just to show you what kind of parameters we're going to use, or rather what kind of configuration we're going to use for this tutorial. So you can see there's basically two groups of the configuration parameters. Those first one, they're related mostly to the functionality of the unit itself. So for example, the first one is the data endian. It's by default big endian. I'm going to keep it that way. This servo drive has 4 inputs, as you can see. So you can choose functionality for each one. So from the up down menu, there's the available selection, so you can select one that you need. And then also for each input, you can select the active level, either high or low. I want to point out to you also there's the input 3 and 4 functions. They could be special type of the functions in case if you have that STO version. STO meaning for the safe torque off. So in case that you have that type of servo drive, input 3 and input 4 are dedicated just for that purpose. And then you have to select, as you can see, STO-A input, STO-B input. You have to select those two, and also you have to select that the inputs have active high. If you select anything else, the unit gonna report as a configuration error. So just keep that in mind. And then second group of the configuration parameters are related mostly to the tune-up of the servo. So you can see down here velocity loop proportional gain, velocity loop integral gain, position loop, proportional integral, and derivative gain. Those are here, just like all of them, are default values. And what particularly means for those gain default values, basically they are related to the unit that doesn't have any load. So basically I would say out of box, and I'm gonna keep it that way because I'm gonna use unit without any load. Also, maybe you already noticed, if I go with my mouse over one of those properties, then you can see there is the pop-up help that talks a little bit about that particular parameter. So that could be handy. Of course, if you need more info about that particular parameter, then you have to go to user manual and take a look there. Okay, so I'm gonna close it, and then, as I said before, I'm gonna use that library and import all the ingredients from the library, and then use those ingredients, those components, to build a program. Okay, so to do that, simply go to libraries, then open the library. So you have to find the place that you downloaded and save that library, and click to open. Okay, so there's you can see 4 folders. First one, the data blocks. For this tutorial I'm gonna need only 2 of them, the input data and output data. So data block input data is gonna contain all the data that we are reading from the server drive, and the command output data is gonna contain all data that we want to send to the server drive. So I'm gonna select these 2 and just simply use drag and drop into the program. Next, I'm gonna go to functions. You can see a list of all available functions. So also I'm gonna select some that we're gonna need for this tutorial. For example, absolute move, then jog moves. Also I'm gonna select motor preset position, relative move, and right there, and stop jog move. Okay, I believe that should be enough. And also just drag and drop. Then also I'm gonna import the tags because it's handy. I have them already, a bunch of those values pre-tagged, so it's much easier to populate it in a program. So I'm gonna also select this one and drop here. Of course, when you import, you can redefine all those tags to your needs. And also I'm gonna grab that run moves watch and force table and drop here. Okay, so I believe we are all set. I can even close the library. Okay, so now it's time to start to build the program. I'm gonna open the main one. So the first thing that I usually do is to read the data. So we have to read the data from the server drive. All our drives belongs to the distributed I/O. So in that section I'm gonna find those 2 instructions that we usually using in all our programs. So you can see dp read and dp write data. Both of them gonna be used in this tutorial as well as in sample programs. So I'm gonna grab right now reading data, and then we have all these 3 parameters. We have to add them. Over here we have to point out where that instruction is supposed to read data from. Basically we have to point to our unit, scroll down. Over here is that so-called hardware ID. So as you can see, that SC160 20 bytes in. Okay, so I'm gonna select, and then to record, and we're gonna record, as I said a few minutes ago, into the data block input data. So I'm gonna select that. And also there's that instruction has the return value that if everything works fine, return value is 0. If there is any issue during execution of this instruction, there will be some error code. So maybe it could help you to troubleshoot the problems. So that should be it. And also I don't want to put any condition. I want that instruction going to be executed at every scan. So basically we have all the time to update data from the server to know what's going on with all status beats, positions, and so on and so forth. So the next thing, for example, I'm gonna grab and let's say function preset the motor. Also one relatively simple function, only we have to add the tag that's going to contain the value, basically what we want to preset to position. Now we need some condition, of course. We need to select when we want to be executed. So I'm gonna go to the comparators and grab that comparator. In this program, just like in sample program, I'm using that control tag, simply control tag, and then just giving different values. For example, when it's value 1, this function is going to be executed. Of course, in your program you can change to anything else that is more suitable to you. Let's say next I'm going to grab the relative move. Okay, now we have a little bit more of things. So we have to populate all those input parameters like target position, program speed, acceleration, deceleration, and so on and so forth. So as I said, I have that PLC tags are already imported, so it's relatively easy to just populate them. Okay, so this is the relative move target position, relative move programmed speed, relative move acceleration, relative move deceleration, peak torque. If you need to add also peak torque, you can add acceleration jerk, and then also that bitwise command, do we want to apply peak torque or not. So, and also what kind of a move is going to be, standard or indexed move. Okay, so this function has three outputs. As you can see, input error, command error, configuration error. Basically, during execution, it monitors all the time those three possible errors, either input error, command error, configuration error. If any occurs, it's going to set those 3 bits and let us know that something is not correct. So input error, then command error, and possible configuration error. Okay, and also we have to add the condition, so I'm going to use the same control tag, and then let's say when it's 2, the relative move is going to be executed. So now I'm going to continue to add all the rest of those functions into the program, and then we're going to continue with this tutorial. Now I have added all the rest of the functions, and before I go any further, I just want to point out, maybe I haven't before, why we using this particular instruction to read the data. So that particular instruction, when it reads consistent data. So why is that important? When we read those 20 bytes of input data from the servo drive, we need to read them consistent without any interruption to preserve that consistency, and this particular instruction does it for us. Okay, so we're gonna go further. So that's the kind of condition when we control 1 is going to be executing motor position, but we have before. That's the relative move, and then what I added, absolute move, same way added all those input parameters, standard output parameters. Then we have that clockwise jog move, then we have the counterclockwise jog move, and on the end we have that function that's going to simply just stop any jog move. Okay, and also I'm going to quickly open this function that I also imported. So basically this is the function that we call when we want to send the data to our servo drive, basically send any command. So this is the dp write data. So what it does, basically it goes the other way around, reading data from that command output data data block, and then send to our unit. So over here there's the so-called hardware ID of our unit. So as you can see, that SV160 20 bytes out, and also this instruction, just the other one, has its own return value. So over here in that data block for the output data, first we put all the data that we want to send, and then just call these instructions to actually send to the servo. And of course this one, just like the other one, preserves the data, so that consistency, sending all 20 bytes at the same time. Okay, I'm gonna close this, and I believe we are pretty much done with the adding all these functions. So those few basic moves. So I go here and compile whole thing, configuration and programs, and then I'm gonna download to the PLC. Okay, then I'm gonna go online. Okay, now we're online, everything looks good so far. We have that PLC communicate to our units, and before go any further, I just want to quickly open that data block input data to see the stored data that is read from the server drive. So I'm gonna monitor. So you can see all those first 32 bits, those status bits. So they're tagged just bit by bit. So if you need in your program for any reason to monitor and then use that status to make any decision in your program, you can just come here and grab those tags. As you can see, for example, the heartbeat is turning on and off. It means that our unit communicates and, so to say, it's alive, right? So there's all of those status bits, and then after status bits we have that motor position and encoder position and all other data. So you can see the values. Looks fine so far, so I'm gonna stop monitoring and close it. So at this point I believe we could go and run some moves. Now we should be able to perform some basic moves like relative move, absolute move, and jog move. To run those moves, I'm gonna open that run moves watch table, also imported from the library, and there are already all those needed tags. If you remember, those all tags are input parameters for those functions like relative move, absolute move, jog move, and so on and so forth. So I already organized them. So all these are related to the relative move, those for the absolute move, jog move, other common for the all moves. And also on the bottom I have just pulled some data, input data from that input data block. As I said, we can read directly from them, from that data block. And then also on the top, that one that I gonna need to select what kind of function we're gonna, or what kind of move we're gonna execute, the control. So if the control is 1, we're gonna preset motor position, 2 for relative move, 3 for the absolute move, and so on and so forth. Okay, so I'm gonna go to monitor and select for example, start with the jog move. For the jog move, let's say I'm gonna start with that 20,000 the speed, and then I'm gonna use also maybe 500 and 500 acceleration in deceleration. Also then for all those moves I'm gonna just simply use standard move, and maybe okay, we can apply or don't apply the peak torque. That in this case it shouldn't matter. So even I'm gonna select them all and keep them false. Then what else? Right now I believe we all set, so we can start with the jog move. I'm gonna select for the jog move clockwise 4 and select. So as you can see, it moves in clockwise direction. Now I can change the speed, so to say on the fly. For example, I can go and double the speed, so put 40,000, just reapply, and you can see the speed doubled. Now I can stop it, just entering 6, it should stop, and then entering 5, it should go to the counterclockwise jog move. So you can see it turning the other way. Also I can change the speed. For example, I can go, let's say, to 30,000 and reapply, and then it's gonna slow down a little bit. Okay, as you can see, the jog move is really straightforward. Now I'm gonna stop it, and then I'm gonna perform a relative and absolute move. So for that purpose I'm gonna preset the position to 0, because then it's easier to see, you know, when we send the unit to certain position, that it really goes to that particular position. So for that reason I'm gonna apply 1, and also preset position, active it, and it's gonna be preset to 0. Okay, so when I hit here, so as you can see, the position now is preset to 0, and then I'm gonna, let's say, apply the relative move. So I have to put some numbers. Let's say 3500,000. Over here the speed we can set 35,000. Acceleration, deceleration, let's say 600, and I don't know, let's say 800. Okay, so that should be good. Now only I have to set for the relative move to 2 and execute. So as you can see, it rotates, and it's supposed to go, because we start from 0, it's supposed to go to 350,000 position. Yeah, and it stops. Then, for example, I can go back and forth if I want to, let's say, go back to 20,000. So I'm gonna go, let's say, so go back by 200,000 and execute again the relative move. So you can see it's gonna go back by minus 100,000 steps and stop and at 150,000 steps. Okay, so next we can do the absolute move. So with absolute move we have to say not by far how to go, but the exact position to go. For example, I can say, let's say, minus 10,000 position. We can show speed 40,000 and acceleration, deceleration 650, and then select for the absolute move 3. So now the motor is supposed to turn and end up with that position, exact position, minus 10,000. So it goes backwards, of course, to reach that position, and stops at that minus 10,000 position. So I can go, for example, and execute again the relative move. Let's say go 400,000 from this position, and it's gonna go by that much steps, so but reduce with the minus 10,000 because we started from minus 10,000. So end up there, and then let's say we can go back, let's say, to 0. So I'm gonna go absolute move to 0 and execute like 3. Okay, so as you can see, this thing is pretty straightforward. You can easily execute jog move, relative move, absolute move. So this tutorial shows that performing basic moves with the AMCI servo drive is one fairly easy task, particularly when using our sample programs and or supplemented library. Thank you for watching this tutorial. Should you have any question, please contact us and we will be more than happy to help you.